ഗുഡ് ഈവനിങ്. കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ അനലിറ്റിക് ഫങ്ഷൻ, അതിൻ്റെ പ്രോപ്പർട്ടീസ് മീൻസ് സം ഓഫ് ടു അനലിറ്റിക് ഫങ്ഷൻ, വെദർ ഇറ്റ് ഈസ് അനലിറ്റിക് ആൻഡ് പ്രോഡക്റ്റ് ഓഫ് ടു അനലിറ്റിക് ഫങ്ഷൻ അനലിറ്റിക് ആണോ, കോഷ്യൻ്റ് ഓഫ് ടു അനലിറ്റിക് ഫങ്ഷൻ അനലിറ്റിക് ആണോ എന്നുള്ള കാര്യങ്ങളെല്ലാം കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ ഡിസ്കസ് ചെയ്തു. ഈ വീഡിയോയിൽ നമ്മൾ ചെയ്യാൻ പോകുന്നത് എന്താ വെച്ച് കഴിഞ്ഞാൽ കോമ്പോസിഷൻ ഓഫ് ടു അനലിറ്റിക് ഫങ്ഷൻ അനലിറ്റിക് ആണ്. അതുപോലെ എങ്ങനെയാണ് അവിടെ ഡെറിവേറ്റീവ് ഡിഫൈൻ ചെയ്യുന്നത്. എഫ് കോമ്പോസിഷൻ ജി ഡാഷ് ഓഫ് ഇസഡ്, എഫും ജിയും ടു അനലിറ്റിക് ഫങ്ഷൻസ് ആണെങ്കിൽ. സോ ദിസ് ഈസ് വൺ തിയറം. Suppose f and g are two analytic functions on f is analytic on g, capital letter G, and omega respectively. Suppose f and g are two analytic functions on g and omega respectively. Also, f of g is suppose that f of g is contained in omega. Then the composition. Here which composition we take? Then f of g is contained in omega, so g composition f. G composition f is from where to where? G composition f is from capital letter G to codomain of this G. What is the codomain of G? Codomain of G means G is from omega to C, F is from G to C, and G is from omega to C. So G composition F is from G to C. Is it clear? So if f and g are two analytic functions on capital letter G and omega respectively, and also f of g is contained in omega, then you can consider the composition function G composition f. It is also analytic. And G composition f dash of z is equal to G of f of z into f dash of z. G composition f of z for z belongs to G. This we want to prove. What we need to prove? This theorem, what your theorem says, suppose f and g are two analytic functions on g and omega respectively. Also f of g is contained in omega. Then you can consider the composition function G composition f. It is from G to C. It is also analytic. And G composition f dash of z. This we can one name. I think this theorem has a name. Chain rule. G composition f dash of z is equal to G of f of z into f dash of G dash of f of z into G dash of f of z into f dash of z. One correction, G dash of f of z into f dash of z. So we need to prove two cases in this theorem. First we need to prove that G composition f is analytic. Then we have to show that G composition f dash of z is equal to G dash of f of z into f dash of z for z belongs to G. So first I want to prove the case G composition f is analytic. G composition f is analytic. So how we show that G composition F is analytic? Analytic on G composition F is analytic on where? G. So to prove G composition F is analytic on G, we have to show that for each point, for each, suppose we take the point as Z0. Suppose you choose an arbitrary point Z0 from G. Then to prove G composition F is analytic on G, you need to show that G composition F is differentiable at each point of some neighborhood of Z0. So to prove G composition F is analytic on G, we need to show that G composition F is analytic at each point of G. So we take an arbitrary point Z0 from G. To prove G composition F is analytic at this point, this is a set, this is a point. When will we can say that a function is analytic at a point? A function is analytic at a point if we can find at least one neighborhood for that point. In that neighborhood, at each point of that neighborhood, the function has a derivative. Is it clear? So Z0, you just take an arbitrary point from G and let it be Z0. Now, what is our aim? We have to show that G composition F, the derivative of G composition F exists at each point of some neighborhood of Z0. So you just take a neighborhood. Suppose for defining a neighborhood, we need a radius and a radius. So you just take R as the radius of that neighborhood. So B Z0 R. You just take this neighborhood. B Z0 R. This is a neighborhood for your Z0. You have to show that G composition F has derivative at each point of this neighborhood. To prove G composition F is analytic, we want to find out at least one neighborhood for G composition, at least one neighborhood for Z0. At each point of that neighborhood, the derivative of G composition F exists. Is it clear? So here we take the neighborhood as B of Z0 R. What this set means? B of Z0 R, it is a set of all points Z belongs to C such that modulus of Z minus Z0. So here we can replace this C by G. You take Z0 from G. So set belongs to G such that modulus of Z minus Z0 less than R. This neighborhood. Okay, so at each point of this neighborhood, we have to show that the derivative of G composition F exists. First, we will prove G composition F is differentiable at this point. How we will show G composition F is differentiable at Z0? So to prove how we can define the derivative of a function F from, suppose in my previous video I explained this thing. F from some x to C and A belongs to X. How we can say that our F is differentiable? This is an open, suppose this is an open set. how we can show that, അല്ലെങ്കിൽ how we can say that your f is differentiable at this point A. F is differentiable at this point A if limit h tends to 0 f of a plus h minus f of a by h exists. If this limit exists, we can say that f is differentiable at this point, and this limit we can take it as the derivative of this function at a. So here we need to show that our G composition f is differentiable at z naught. So suppose you just take, instead of h, you just take hn. Then what is the limit you want to consider here? Limit hn tends to 0, limit hn tends to 0, f of, sorry, G composition f of, at this point you have to show that our G composition f is differentiable. So limit hn tends to 0, limit hn tends to 0, limit hn tends to 0, G composition f of z naught plus hn, z naught plus hn minus G composition f of z naught, f of a plus h minus f of a. So G composition, instead of f here, G composition f. So G composition f of z naught plus hn minus G composition f of z naught. You just compare with this definition. So divided by, what is the term you want to put here? Hn. Limit hn tends to 0, G composition f of z naught plus hn minus G composition f of z naught divided by hn. To prove G composition f is differentiable at this point, you need to verify whether this limit exists or not. If this limit exists, then one more thing you need to show. What is the remaining thing you need to show? G composition derivative is equal to G dash of f of z into f dash of z. Okay, so what about this limit? We find this limit by two cases, by using in two cases. In the first case, case 1, you just take what we need to take here, f of z naught plus hn not equal to f of z naught. Suppose this f of z naught plus hn not equal to f of z naught. So you can convert this limit by adding, by dividing and or multiplying some terms. You can convert this limit. How you can convert this limit is, so you just keep this term in your mind. Then you have to convert this term. How you can convert this term? So adjust it. This is equal to limit hn tends to 0, limit hn tends to 0, f of z naught plus hn minus, sorry, not f of z naught plus hn, G composition f of z naught plus hn minus G composition f of z naught divided by f of z naught plus hn. Here G composition f of z naught plus hn Here f of z naught plus hn minus f of z naught into. So here we take this term. So you have to cancel this term. So you just multiply with this term. F of z naught plus hn minus f of z naught. So these two terms get cancelled. Divided by, what is the remaining term here? hn. Okay. So you just transform this term into limit hn tends to 0, G composition. Here we take the case as f of z naught plus hn not equal to f of z naught. So f of z naught plus hn minus f of z naught not equal to 0. So this is defined. This is not equal to 0. So G composition f of z naught plus hn minus G composition f of z naught plus hn minus G composition f of z naught. Clear idea? G composition f of z naught divided by, you multiply and divide with the term f of z naught plus hn minus f of z naught. So here your case is like this. So you can divide this term with f of z naught plus hn minus f of z naught, since it is not equal to 0. So the denominator is not equal to 0. So you can divide with f of z naught plus hn minus f of z naught. Okay. These things you keep it in your mind.